Alrighty guys, so these are the notes, and this is the sort of answer key for interpreting slope from a graph from our notes pages. If you have not actually even looked at this zine, you need to pause this video right now, do the 6 problems inside of it, and then restart this video. Please be honest with yourself. If you don't choose to be honest with yourself, you are only creating a world of hurt for you. So please make sure you go through this zine prior to watching this video. Anyways, this is what the zine looks like. Let's begin. Very first page, we're figuring out the units as well as the actual slopes that we have going on and interpreting them. We're trying to figure out what they truly mean. So in this one, we can find those nice points that this line crosses the graph. For Paul, you can see that I just did them really lightly in red. So I can see that our slope is a rise of 5. And if I want to think about that, it's in dollars. So I have $5 increasing for every 1 hour worked. Typical kid's job. So we could say that our slope is 5 over 1, 5 over 1, 5 over 1. So slope is equal to $5 over 1 hour. I do expect you to have labels on your answers. So let's go to the next one. Donna's yard service. Here we go. Donna, how much are we increasing every time? If I look at the top, there's a reason why I'm only looking at the bottom right now. If I look at the top, we're increasing by 1 each time. What does that 1 mean? 1 hour. So we're increasing by 1 hour each time. And how much are we increasing by with 1 hour each time? $6. $6 is happening every single time we increase by an hour. So the slope in this situation is $6 per 1 hour. So Donna's yard service charges $6 per 1 hour. If I were even to look, though, and scale backwards, so if I were to subtract $6 and find out how much it's going to be if I essentially hired her but said, oh, but actually today I don't need anything done, she is going to charge me $5 no matter what. So I could even write an equation of y is equal to that $6 in 1 hour times x plus this $5 is my y-intercept. So I can actually interpret all of this and actually turn it into an equation. So Donna charges $5 just to show up, and then after that she's charging $6 an hour on top of that. Next, this delivery service charge. Let's look at this. We are increasing $7. So we're doing that every single time we're in, oops, I am on the wrong thing. We're increasing by $7 each time. And then we can look at this on the left-hand side, and we are increasing by 1 mile each time. So this delivery service is charging $7 for every 1 mile they travel. Again, we can do the exact same thing that we did with Donna's yard service, and we could go actually backwards, and we could figure out how much they're going to charge just to deliver something maybe. So maybe those people who are living in the exact same building as this delivery service, they are being charged, if we took that $14 and subtracted $7 from it, they're being charged $7 no matter what just to have that delivery service. So we could say y is equal to that same idea of the $7 per 1 mile times x miles plus a base charge of $7. Kind of interesting. It's kind of a little bit of a crackpot situation there. I don't think I need to pay a delivery service just to run something maybe up the stairs or right next door or something like that. But whatever, maybe people are really busy. So let's look at the next one. Todd. Todd has an account. He has an account. It looks like it's a bank account. He has a lot of money in it for a number of years. Let's figure out what the slope is. It looks like his slope has a rise, because we're always talking rise over run. It has a slope rise of 100 what? Dollars. Rise of $100 per every 10 years. So he either is not investing very much very often, or maybe he's just put money into this account and over 10 years he has gained $100 in interest. That is fully possible. So what we can do is we can put this rise over run into action into this. We have $100 over 10 years. And if I want to figure out the unit rate, so like 1 year, we could divide the top and bottom by 10, because they both can be divided by 10, and we'll get $10 of money accrued in interest per 1 year. Sweet. Awesome. Great, Todd. Good investing. It's actually a better bank account than what I have. Last but not least, we have oil in our tank. Oh, actually, it's not last but not least. I think I have one more after this. So, we are looking at oil in an oil tank. To start out with, again, I am looking at my slope and I'm finding those nice places where this line crosses on the graph. Notice these nice places. Very cool. Awesome. Now I need to figure out how much I am increasing versus how much I'm increasing in the y-axis versus how much I'm increasing in the x-axis. It looks like we don't necessarily know the gallons. We don't know the numbers on the left-hand side, but that doesn't mean we can't actually figure this out to a certain extent. Let's actually just give it a random unit. Every time I increase here, I have 1 gallon, 2 gallons, 3 gallons, 4 gallons. So I could say that I am increasing by 2 gallons vertically for every 5 minutes. So it looks like oil in the oil tank is increasing 2 gallons every 5 minutes. Sounds like they're filling up that tank. Oops, that's not a 2, that was almost a 5. 2 gallons in 5 minutes. I hope you have gotten the hang of this. Last but not least, let's go to the very last problem. Here we go, weight in pounds versus length of spring. Essentially, we have a spring that has a little weight on it, and depending on how much weight is there, the spring will stretch. So, let's look at this. How much is the weight in pounds increasing by each time? Looks like ½ pound. So then we can also look at the bottom part, and it looks like we're increasing by 0.8 inches, 0.8 inches each time. So our slope for this is we are increasing by 0.8 inches per ½ pound. Now, personally, I really don't like decimals in my or I don't like decimals, at least at the very bare minimum, in the denominator of things that I write for slope. So let's turn this ½ pound into 1 full pound. And if I do that, I had to multiply by 2 to make that happen. So I'm going to multiply by 2 on the top as well. Whatever I do to the top, I have to do the bottom. And so I'm going to write 1.6 inches. So there's a 1.6 inch increase for every 1 pound that's added to this spring/weight situation. So check your work on all of these. If you have any questions, make sure you save them for when I get back. I'll be back on Tuesday, so you can definitely ask me then. Thank you very much for watching, and I will talk to you later. Thanks.